Question 1. When evaluating the migration of a sensitive customer data schema from an on-premises Oracle database to Amazon RDS for PostgreSQL, what is the most critical step to ensure both data integrity and compliance with data protection regulations, considering the capabilities of AWS Schema Conversion Tool, SCT? Option A. Performing a comprehensive review of the AWS SCT assessment report to identify potential conversion issues and security implications, followed by rigorous testing of the converted schema for functional correctness, performance, and adherence to security controls and auditing requirements. Option B. Relying solely on the automated conversion process of AWS SCT, assuming it will accurately translate all schema objects and their associated security configurations without manual intervention or post-conversion validation. Option C. Prioritizing the speed of migration by deploying the converted schema directly to Amazon RDS for PostgreSQL after a brief automated conversion, deferring detailed security and compliance checks to a later stage. Option D. Ignoring the specific security and compliance features of Amazon RDS for PostgreSQL, such as encryption at rest and in transit, and focusing only on the functional equivalent of the converted schema objects. The correct answer is A. Performing a comprehensive review of the AWS SCT assessment report to identify potential conversion issues and security implications, followed by rigorous testing of the converted schema for functional correctness, performance, and adherence to security controls and auditing requirements. Explanation. Scenario analysis. This scenario presents a common challenge in database migration projects, ensuring data integrity and compliance during schema conversion from a legacy on-premises Oracle database to Amazon RDS for PostgreSQL. The professional challenge lies in balancing the speed of migration with the absolute necessity of adhering to data governance policies and regulatory requirements, particularly concerning data sensitivity and access controls. Failure to properly configure and validate the converted schema can lead to data breaches, compliance violations, and operational disruptions. The AWS Certified Database Specialty exam emphasizes understanding how AWS services integrate with and support these critical business and regulatory concerns. Correct approach analysis. The correct approach involves leveraging AWS Schema Conversion Tool, SCT, to generate an assessment report that identifies potential conversion issues and provides recommendations for addressing them. Crucially, it includes a thorough review of this report by database administrators and security personnel to understand the implications for data access, encryption, and auditing. Post-conversion, a comprehensive testing phase, including functional, performance, and security testing, is essential to validate the converted schema against the original and ensure compliance with all applicable regulations. This methodical approach, prioritizing assessment, validation, and compliance, represents best professional practice because it proactively mitigates risks associated with data migration and ensures that the target database meets security and regulatory standards. AWS services like SCT are designed to facilitate this by providing detailed insights and enabling a structured conversion process. Incorrect approach is analysis. One incorrect approach is to solely rely on the automated conversion capabilities of SCT without a detailed review of the assessment report and subsequent validation. This bypasses critical steps for identifying and rectifying potential compliance gaps, such as the handling of sensitive data or the implementation of appropriate access controls in the target PostgreSQL environment. This failure to perform due diligence can lead to regulatory violations if sensitive data is not adequately protected or if auditing requirements are not met in the new schema. Another incorrect approach is to prioritize speed of migration over thorough testing and validation. This might involve deploying the converted schema directly to production after a cursory review, assuming the automated conversion is flawless. This is professionally unacceptable as it ignores the inherent complexities of schema conversion and the potential for subtle errors that could compromise data integrity or security. Such an approach risks non-compliance with data protection regulations and could result in significant data loss or corruption, leading to severe business and legal repercussions. A third incorrect approach is to ignore the specific security and compliance requirements of the target PostgreSQL environment during the conversion process. For instance, failing to configure appropriate encryption at rest and in transit, or neglecting to implement granular access controls that align with the organization's security policies would be a significant oversight. This directly contravenes best practices for data security and regulatory compliance, potentially exposing sensitive data to unauthorized access and leading to breaches of regulations like GDPR or CCPA, if applicable to the organization's data handling. Professional reasoning. Professionals should adopt a risk-based approach to database schema conversion. This involves 1. Understanding the source and target database environments, including their respective security and compliance implications. 2. Utilizing tools like AWS SCT to gain insights into conversion complexities and potential issues. 3. Conducting a thorough review of SCT assessment reports with relevant stakeholders, DBA security compliance. 4. Developing a comprehensive migration plan that includes pre-migration assessment, conversion, rigorous testing, functional, performance, security, and post-migration validation. 5. Prioritizing data security and regulatory compliance throughout the entire process, ensuring that the target environment meets all necessary standards. Question 2. The performance metrics show that analytical queries for financial reporting are experiencing significant latency, impacting the firm's ability to generate timely regulatory submissions. Given the firm's U.S. regulatory environment, which mandates robust data integrity and auditability, what database technology approach would best address these performance bottlenecks while ensuring compliance? Option A. Migrate to a graph database, focusing on the relationships and connections within the financial data. Option B. Adopt a NoSQL document database, prioritizing schema flexibility for evolving analytical data structures. Option C. Implement a columnar database optimized for analytical workloads, enabling efficient scanning and aggregation of data across specific columns. Option D. Transition to a row-oriented database, which is generally better suited for transactional data processing and frequent individual record access. The correct answer is C. Implement a columnar database optimized for analytical workloads, enabling efficient scanning and aggregation of data across specific columns. Explanation. Scenario analysis. A financial services firm is experiencing performance degradation with its analytical workloads. The challenge lies in selecting the most appropriate database technology for these read-heavy analytical queries, balancing cost, performance, and the need for efficient data retrieval. The firm operates under stringent U.S. financial regulations, requiring robust data integrity, auditability, and performance for regulatory reporting. Misjudging the database technology could lead to compliance issues, increased operational costs, and an inability to meet critical business demands. Correct approach analysis. Choosing a columnar database for analytical workloads is best professional practice because it aligns with the principles of efficient data processing for aggregations and reporting, which are critical for financial services. U.S. regulations, such as those under the SEC and FINRA, mandate timely and accurate reporting. Columnar databases excel at scanning and aggregating data across many rows but few columns, directly supporting the types of queries common in financial analysis and regulatory reporting. This technology minimizes I/O by only reading the necessary columns, leading to faster query execution and improved resource utilization, which is a key consideration for cost-effective operations and meeting performance SLAs mandated by regulatory bodies. Incorrect approaches analysis. Selecting a row-oriented database for analytical workloads would be a regulatory and ethical failure. Row-oriented databases are optimized for transactional workloads where individual rows are frequently accessed and modified. For analytical queries that scan large datasets and aggregate values across specific columns, row-oriented databases would require reading entire rows, even if only a few columns are needed, leading to excessive I/O and significantly slower performance. This inefficiency could impede the firm's ability to generate timely regulatory reports, potentially violating SEC Rule 17a4, record-keeping, or other reporting requirements, and could be seen as a failure to maintain adequate systems and controls. Opting for a NoSQL document database without careful consideration of its suitability for structured analytical queries would also be problematic. NoSQL databases offer flexibility. Many are not inherently optimized for complex analytical aggregations and joins across large, structured datasets. If the analytical workloads involve intricate relationships and aggregations, A document database might not provide the performance required for regulatory reporting, leading to similar compliance risks as a row-oriented database. The lack of strong schema enforcement in some NoSQL types could also introduce data integrity risks, which are critical for financial data. Choosing a graph database would be inappropriate for typical analytical workloads focused on aggregations and time series analysis. Graph databases are designed for managing and querying highly interconnected data, such as social networks or recommendation engines. While they have their place, they are not the optimal choice for the performance-intensive, column-focused queries characteristic of financial analytics and reporting, leading to suboptimal performance and potential compliance delays. Professional reasoning. Professionals should approach this scenario by first understanding the specific nature of the analytical workloads, read-heavy, aggregation-focused, and the regulatory requirements for data access, integrity, and reporting timeliness. A comparative analysis of database technologies, focusing on their strengths and weaknesses for these specific use cases, is essential. This involves evaluating performance characteristics, cost implications, scalability, and compatibility with existing infrastructure and compliance frameworks. The decision should be driven by a clear understanding of how each technology choice impacts the ability to meet both business objectives and regulatory obligations, prioritizing solutions that offer demonstrably superior performance and reliability for analytical tasks. Question 3. Governance review demonstrates that a critical financial reporting database on AWS experiences high read and write concurrency. The application requires that data remains consistent and auditable at all times to comply with financial regulations. Developers are considering different strategies to manage concurrent transactions and prevent data corruption. Which approach best balances performance with the strict requirements for data integrity and auditability in this regulated environment? Option A. Implement optimistic locking with version numbers to detect and resolve conflicts at commit time. Option B. Rely solely on database read replicas to maintain data consistency across all read operations. Option C. Utilize pessimistic locking for all read and write operations to ensure exclusive access. Option D. Develop a custom, in-application mechanism to track data changes without relying on database-level versioning. The correct answer is A. Implement optimistic locking with version numbers to detect and resolve conflicts at commit time. Explanation. Scenario analysis. This scenario presents a common challenge in database management within regulated environments, ensuring data integrity and consistency during concurrent operations while adhering to strict compliance requirements. The challenge lies in balancing the need for high availability and performance with the imperative to prevent data corruption and maintain auditability, especially when dealing with sensitive financial transactions. The AWS Certified Database Specialty exam emphasizes understanding how AWS database services support these critical aspects within a defined regulatory framework. Correct approach analysis. Implementing optimistic locking with versioning is the best professional practice in this context. This approach allows multiple transactions to read data concurrently without acquiring locks, thereby improving performance and reducing contention. When a transaction attempts to commit, it checks if the data it read has been modified since it was read by comparing version numbers or timestamps. If a modification is detected, the transaction is aborted and retried. This aligns with regulatory principles that mandate data accuracy and integrity. By detecting conflicts at commit time and allowing for retries, it ensures that only valid, consistent data is persisted, preventing race conditions and data corruption. This method is often preferred in high-throughput systems where the probability of conflicts is low and the overhead of pessimistic locking would be detrimental. Incorrect approaches analysis. Using pessimistic locking, e.g., row-level locks, for all read operations would be a regulatory and ethical failure. While it guarantees data consistency by preventing concurrent writes to the same data, it significantly degrades performance and can lead to deadlocks, especially in a high concurrency environment. This inefficiency could violate service-level agreements, SLAs, and impact the ability to meet regulatory reporting deadlines, which are often time-sensitive. Furthermore, the potential for deadlocks introduces an unacceptable risk of data unavailability or corruption if not handled meticulously, which is a direct contravention of data integrity mandates. Implementing a custom, ad hoc mechanism for tracking data modifications without a robust versioning or timestamping strategy is also a significant regulatory and ethical failure. Such an approach is prone to errors, difficult to audit, and lacks the proven reliability of established concurrency control mechanisms. It would be virtually impossible to demonstrate compliance with data integrity and auditability requirements to regulators, as the custom solution would not be subject to the same scrutiny and validation as standard database features. This lack of auditable control is a direct violation of principles requiring transparent and verifiable data handling. Relying solely on database-level read replicas for consistency without a clear strategy for handling write conflicts would be a regulatory and ethical failure. Read replicas are designed for read scalability, not for managing concurrent write operations and their associated integrity challenges. If write operations are not properly coordinated across the primary and replicas, or if the application logic does not account for potential conflicts arising from concurrent writes, data inconsistencies can occur. This undermines the fundamental requirement for accurate and consistent data, making it impossible to meet regulatory obligations for financial reporting or operational integrity. Professional reasoning. Professionals must adopt a decision-making framework that prioritizes data integrity, auditability, and performance within the bounds of the applicable regulatory framework. This involves understanding the trade-offs between different concurrency control mechanisms. When faced with a scenario requiring high concurrency and strict data integrity, the first step is to identify the specific regulatory requirements related to data accuracy, consistency, and auditability. Then, evaluate how different database features and concurrency control strategies, like optimistic and pessimistic locking, can meet these requirements. The chosen approach should be demonstrably robust, auditable, and aligned with best practices for the specific AWS database service being used. Performance considerations should be balanced against these critical compliance factors. Question 4. The risk matrix shows a critical vulnerability in the AWS RDS for PostgreSQL instance that was exploited, leading to a data exfiltration incident. The immediate business priority is to restore full database functionality. Which of the following actions best balances the need for rapid service restoration with robust vulnerability management? Option A. Restore the database from a pre-incident backup and focus solely on data recovery, deferring any vulnerability assessment until after normal operations are resumed. Option B. Initiate a full forensic analysis to identify the specific exploit vector, apply a targeted fix for that vulnerability, and then conduct comprehensive security retesting before full service restoration. Option C. Rely on AWS's automated security patching to address the vulnerability and proceed with data recovery, assuming AWS will resolve the issue. Option D. Immediately apply the latest general security patch for PostgreSQL and restart the instance, then proceed with data recovery. Correct answer is D. Immediately apply the latest general security patch for PostgreSQL and restart the instance, then proceed with data recovery. Explanation. Scenario analysis. This scenario is professionally challenging because it requires balancing the immediate need for operational continuity with the long-term imperative of robust security. The pressure to restore service quickly can lead to shortcuts that introduce new vulnerabilities or fail to address the root cause of the initial breach. Furthermore, the organization's reliance on a specific AWS database service introduces a dependency on AWS's shared responsibility model, necessitating a clear understanding of where AWS's security obligations end and the customers begin. The complexity of cloud-native database environments, with their dynamic nature and extensive configuration options, demands a nuanced approach to vulnerability management that goes beyond traditional on-premises methods. Correct approach analysis. The correct approach represents best professional practice because it prioritizes a comprehensive and systematic response that addresses both immediate remediation and future prevention, aligning with the principles of secure cloud operations and data protection. This approach acknowledges that a successful vulnerability management program involves continuous assessment, timely patching, and proactive threat hunting. By focusing on identifying the root cause of the vulnerability, implementing targeted patches, and then conducting a thorough security review and retesting, the organization ensures that the immediate threat is neutralized and that the underlying security posture is strengthened. This aligns with the general principles of data security and incident response expected in regulated environments, even without specific U.S. regulatory citations, as it demonstrates due diligence and a commitment to maintaining the confidentiality, integrity, and availability of data. The emphasis on retesting confirms the effectiveness of the remediation and prevents the recurrence of similar incidents. Incorrect approach is analysis. An approach that solely focuses on restoring service without a thorough vulnerability assessment and remediation plan is professionally unacceptable. This failure to identify and address the root cause of the breach leaves the system susceptible to re-exploitation, violating the ethical obligation to protect data and maintain system integrity. It demonstrates a lack of due diligence and a reactive rather than proactive security stance. An approach that involves applying generic security patches without understanding the specific vulnerability exploited or its impact on the AWS database service is also professionally flawed. This can lead to ineffective remediation, potential service disruption due to incompatible patches, or the introduction of new, unforeseen issues. It signifies a superficial understanding of the problem and a failure to apply targeted, effective solutions. An approach that relies solely on AWS's automated security features without independent verification and targeted remediation is insufficient. While AWS provides robust security tools, the customer is ultimately responsible for configuring and managing their environment securely. Over-reliance on automation without active management and validation can lead to overlooked vulnerabilities or misconfigurations that a determined attacker could exploit. This demonstrates a misunderstanding of the shared responsibility model and a failure to exercise appropriate oversight. Professional reasoning. Professionals should adopt a structured incident response and vulnerability management framework. This involves 1. Containment and eradication. Immediately isolate the affected systems to prevent further damage. 2. Identification. Conduct a thorough forensic analysis to understand the nature of the vulnerability and how it was exploited. 3. Remediation. Develop and apply targeted patches or configuration changes to fix the vulnerability. 4. Verification. Rigorously test the remediation to ensure it is effective and has not introduced new issues. 5. Lessons learned and prevention. Document the incident, update security policies and procedures, and implement measures to prevent recurrence. This systematic approach ensures that immediate threats are addressed while also strengthening the overall security posture. Question 5. The evaluation methodology shows that a financial services organization is migrating sensitive customer data to Amazon RDS. To comply with U.S. federal regulations regarding data protection and access control, which of the following approaches best ensures that only authorized applications and personnel can access and manipulate this data, while maintaining a comprehensive audit trail of all access activities? Option A. Disabling all logging mechanisms for Amazon RDS to reduce operational overhead and potential data exposure. Option B. Implementing granular access control policies within AWS Identity and Access Management (IAM) to define specific permissions for database access and ensuring that database access is logged via AWS CloudTrail. Option C. Relying solely on native database user accounts and passwords for authentication and authorization, without integrating with AWS IAM. Option D. Granting broad administrative privileges to all entities that require access to the Amazon RDS instance to simplify management. The correct answer is B. Implementing granular access control policies within AWS Identity and Access Management (IAM) to define specific permissions for database access and ensuring that database access is logged via AWS CloudTrail. Explanation. This scenario presents a professional challenge because it requires balancing robust security controls with operational efficiency and compliance with U.S. federal regulations governing data access and protection, specifically within the context of cloud-based database services. The need to ensure only authorized personnel can access sensitive customer data stored in Amazon RDS, while also adhering to principles of least privilege and auditability, demands careful consideration of authentication and authorization mechanisms. The correct approach represents best professional practice because it leverages AWS Identity and Access Management (IAM) to enforce granular access controls by creating specific IAM roles with precisely defined permissions for database access and associating these roles with the applications or users that require them. Organizations can implement the principle of least privilege. This minimizes the attack surface by ensuring that entities only have the permissions necessary to perform their intended functions. Furthermore, integrating with AWS CloudTrail provides an auditable log of all API calls, including database access attempts, which is a critical requirement for regulatory compliance and incident investigation under U.S. federal guidelines. This approach directly addresses the need for strong authentication via IAM roles/users and authorization via IAM policies, while maintaining a clear audit trail. An incorrect approach that relies solely on database-native user management without IAM integration fails to provide centralized control and comprehensive auditing capabilities mandated by many U.S. federal regulations. While database users can authenticate, managing these users across multiple databases and ensuring consistent, least privilege authorization becomes complex and error-prone. This lack of centralized oversight makes it difficult to demonstrate compliance and respond effectively to security incidents. Another incorrect approach that grants broad administrative privileges to all database access entities, even if authenticated, violates the principle of least privilege. This significantly increases the risk of unauthorized data modification or deletion, even by well-intentioned but misconfigured applications or users. Such broad access is a direct contravention of security best practices and regulatory expectations for protecting sensitive data. Finally, an approach that bypasses standard authentication and authorization mechanisms, perhaps through direct network access or shared credentials, introduces severe security vulnerabilities. This is fundamentally non-compliant with U.S. federal data protection mandates, which require strict controls over access to sensitive information. It creates an unmanageable and unobservable environment, making it impossible to ensure data integrity and confidentiality. The professional decision-making process for similar situations should involve a thorough understanding of the data sensitivity, the applicable U.S. federal regulatory requirements, e.g., HIPAA, PCI DSS, NIST guidelines, and the capabilities of the cloud platform. Prioritizing a centralized, policy-driven approach to authentication and authorization, such as AWS IAM, is crucial. This should be combined with robust auditing and logging mechanisms to ensure continuous monitoring and compliance. The principle of least privilege must be a guiding tenet throughout the design and implementation process. Question 6. Stakeholder feedback indicates a critical need for a distributed database solution on AWS that can maintain near real-time data synchronization across multiple geographic regions, while ensuring that users can always access and modify their data, even if network connectivity between regions is temporarily disrupted. The primary business objective is to minimize any user-facing downtime. Which of the following architectural approaches best addresses these requirements within the constraints of distributed systems? Option A. Select a database service that prioritizes strong consistency and availability, designing the application to halt operations in any region experiencing a network partition until full connectivity is restored. Option B. Select a database service that guarantees absolute consistency and availability, assuming that network partitions are an edge case that will not impact the system's core functionality. Option C. Select a database service that offers tunable consistency and design the application to tolerate potential temporary inconsistencies during network partitions, ensuring continuous data access and modification. Option D. Select a database service that prioritizes availability and partition tolerance, accepting that data in different regions may become temporarily inconsistent, and designing the application to resolve these conflicts only after connectivity is fully restored. The correct answer is A. Select a database service that prioritizes strong consistency and availability, designing the application to halt operations in any region experiencing a network partition until full connectivity is restored. Explanation: this scenario presents a professional challenge due to the inherent trade-offs dictated by the CAP theorem when designing distributed database systems. Stakeholders, focused on business continuity and user experience, often prioritize high availability and data consistency, unaware of the fundamental limitations imposed by network partitions. The challenge lies in translating these business requirements into a technically sound database architecture that adheres to AWS best practices and, by extension, the principles of robust cloud database design relevant to the AWS Certified Database Specialty Exam. Careful judgment is required to balance these competing demands within the constraints of distributed systems. The correct approach represents best professional practice because it acknowledges the CAP theorem's limitations and proactively designs for partition tolerance, a critical aspect of distributed systems operating in a cloud environment. By choosing a database service that offers tunable consistency and designing the application to handle potential inconsistencies during partitions, the team is building a resilient system. This aligns with the AWS Well-Architected Framework's reliability pillar, which emphasizes designing for failure and ensuring systems can recover from disruptions. Specifically, for a US-based context, this approach indirectly supports compliance with regulations like SOX, Sarbanes-Oxley Act, by ensuring data integrity and availability, which are crucial for financial reporting and auditability, even under adverse network conditions. The focus on understanding and mitigating the impact of partitions is a hallmark of professional database architecture in a distributed cloud setting. An incorrect approach that prioritizes absolute consistency over availability during network partitions would fail professionally. This is because it would lead to system downtime for users in affected regions, directly contradicting the business requirement for high availability. From a regulatory perspective, particularly in the US, prolonged downtime can have significant financial implications and may violate service-level agreements, SLAs, with customers, potentially leading to penalties and reputational damage. Such a choice demonstrates a lack of understanding of distributed system trade-offs and a failure to design for real-world network instability. Another incorrect approach that sacrifices partition tolerance for high availability and strong consistency would be equally problematic. While seemingly offering the best of both worlds, it is technically infeasible in a truly distributed system. Attempting to achieve this would likely result in a system that is either not truly distributed or fails to meet its consistency or availability guarantees under partition conditions. This leads to a false sense of security and a system that is brittle and prone to unexpected failures, which is a significant professional and ethical failure in system design. It also fails to meet the implicit expectation of resilience in cloud-native applications. The professional decision-making process for similar situations should involve a thorough understanding of the CAP theorem and its implications for the specific database service being considered. This includes 1. Clearly defining business requirements for consistency and availability. 2. Evaluating the inherent trade-offs of different database services on AWS in the context of these requirements. 3. Designing the application layer to gracefully handle potential data inconsistencies or temporary unavailability during network partitions. 4. Conducting rigorous testing to validate the system's behavior under various failure scenarios. This systematic approach ensures that technical decisions are aligned with business objectives and regulatory considerations, leading to robust and reliable database solutions. Question 7. The control framework reveals that a US-based financial services organization is conducting database profiling on an Amazon RDS instance to identify performance bottlenecks. The profiling process involves querying and analyzing large volumes of customer transaction data, which may contain sensitive personally identifiable information, PI, and financial details subject to regulations like the Gramm-Leach-Bliley Act, GLBA. Which of the following approaches best aligns with regulatory compliance and data protection best practices for this scenario? Option A. Perform database profiling directly on the production RDS instance without any specific data transformation, relying on existing network security controls to protect the data. Option B. Utilize AWS Lake Formation's data catalog and access controls to restrict profiling access to only aggregated non-sensitive metrics, foregoing detailed transaction-level analysis. Option C. Conduct the database profiling on the raw, sensitive customer transaction data, and then apply data masking techniques to the profiling results after the analysis is complete. Option D. Implement robust anonymization and pseudonymization techniques on the data before initiating the database profiling process, ensuring that the profiling queries operate on de-identified or pseudonymized datasets. The correct answer is D. Implement robust anonymization and pseudonymization techniques on the data asterisk before asterisk initiating the database profiling process, ensuring that the profiling queries operate on de-identified or pseudonymized datasets. Explanation: the scenario presents a professional challenge due to the inherent tension between optimizing database performance and adhering to strict data privacy regulations, specifically within the context of U.S. federal data protection laws applicable to cloud environments. Database profiling, while essential for performance tuning, can inadvertently expose sensitive data if not conducted with extreme care. The challenge lies in balancing the need for detailed data insights with the imperative to protect personally identifiable information, PI, and other regulated data types. The correct approach represents best professional practice because it prioritizes regulatory compliance and data minimization from the outset. By implementing anonymization and pseudonymization techniques asterisk before asterisk profiling, the organization ensures that the profiling process itself does not create new risks of data exposure. This proactive stance aligns with the principles of privacy by design and by default, which are foundational to U.S. data protection frameworks like HIPAA for health information and potentially other sector-specific regulations or general best practices for handling sensitive data in the cloud. This method minimizes the attack surface and reduces the likelihood of accidental data breaches during analysis. An incorrect approach that involves profiling raw, sensitive data without adequate safeguards represents a significant regulatory and ethical failure. This directly violates the principle of data minimization and could lead to unauthorized access or disclosure of PII, resulting in severe penalties under U.S. federal laws, reputational damage, and loss of customer trust. Another incorrect approach, which relies solely on post-profiling data masking, is less robust. While it attempts to mitigate risk after the fact, the sensitive data has already been processed and potentially logged in its raw form, increasing the risk of exposure during the profiling phase itself. This reactive measure is less effective than a proactive, privacy-by-design strategy. Professionals should employ a decision-making framework that begins with a thorough understanding of applicable U.S. data protection regulations and the specific types of sensitive data being handled. This should be followed by a risk assessment to identify potential vulnerabilities during database operations, including profiling. The chosen profiling strategy must then be evaluated against these identified risks and regulatory requirements, prioritizing methods that inherently minimize data exposure. Documentation of the profiling process, data handling procedures, and compliance checks is also crucial for demonstrating due diligence. Question 8. Cost-benefit analysis shows that implementing a robust data recovery strategy for a critical financial services database is essential to meet stringent business continuity requirements. The organization has a very low tolerance for data loss and requires the ability to restore operations quickly following an incident. Which recovery model approach best aligns with these needs while considering operational efficiency? Option A. A recovery model that logs all transactions and allows for point-in-time recovery, ensuring minimal data loss and flexible restoration capabilities. Option B. A recovery model that prioritizes minimizing storage costs by only performing full backups on a weekly basis, with no transaction logging enabled. Option C. A recovery model that utilizes only simple recovery, which truncates transaction logs after each backup, limiting restoration to the last full or differential backup. Option D. A recovery model that focuses on the lowest immediate infrastructure cost by disabling transaction logging and relying solely on periodic full backups. The correct answer is A. A recovery model that logs all transactions and allows for point-in-time recovery, ensuring minimal data loss and flexible restoration capabilities. Explanation: scenario analysis. This scenario presents a common challenge in database management where balancing recovery objectives with operational costs is paramount. The professional must assess the potential impact of data loss against the expense of implementing and maintaining different recovery models. This requires a nuanced understanding of business continuity needs, regulatory compliance, though not explicitly stated as a constraint in this specific question. It's an underlying professional consideration. and the technical implications of each recovery model. The challenge lies in selecting the most appropriate model that minimizes risk without incurring prohibitive costs, a decision that directly impacts business resilience and financial health. Correct approach analysis. Selecting the recovery model that aligns with the business's recovery point objective, RPO, and recovery time objective, RTO, is best professional practice. An RPO defines the maximum acceptable amount of data loss measured in time, and an RTO defines the maximum acceptable downtime. The chosen recovery model must demonstrably support these objectives. For instance, if near-zero data loss is critical, a model that logs all transactions and allows for point-in-time recovery is essential. This approach ensures that the business can resume operations within acceptable parameters and minimize financial and reputational damage from data loss, thereby meeting implicit business continuity and operational integrity expectations. Incorrect approaches analysis. Choosing a recovery model solely based on minimizing immediate infrastructure costs without considering the RPO/RTO can lead to significant financial and operational repercussions in the event of a failure. This approach fails to adequately address the business's tolerance for data loss and downtime, potentially resulting in losses far exceeding the initial cost savings. This represents a failure in risk management and a disregard for business continuity requirements. Implementing a recovery model that offers the highest level of data protection without a clear business need or justification for its associated operational overhead and complexity is also professionally unsound. While it might seem like a safe option, it can lead to unnecessary resource consumption, increased management burden, and potentially slower recovery times if not properly configured and maintained, deviating from efficient resource allocation and potentially impacting performance. Opting for a recovery model that does not support point-in-time recovery when the business requires the ability to restore to a specific moment in time is a critical failure. This limitation can prevent the business from recovering from specific corruption events or accidental data modifications, leading to irreversible data loss and significant operational disruption. This demonstrates a lack of understanding of the business's specific recovery needs. Professional reasoning. Professionals should approach this by first understanding the business's RPO and RTO requirements. This involves engaging with stakeholders to quantify the acceptable data loss and downtime. Subsequently, they should evaluate the available recovery models, considering their technical capabilities, operational complexity, and cost implications. The decision should be a deliberate trade-off between risk mitigation and resource expenditure, ensuring that the chosen model provides the necessary protection without being overly burdensome. This systematic approach ensures that the database's recovery strategy is aligned with business objectives and operational realities. Question 9. Operational review demonstrates that a financial services firm's critical customer transaction database has experienced intermittent performance degradation due to network latency during peak hours. The firm is subject to strict U.S. regulatory requirements for data availability and recovery. Which of the following approaches to disaster recovery planning, considering the risk assessment phase, best aligns with these regulatory obligations and professional best practices for ensuring business continuity? Option A. Conduct a thorough business impact analysis to define RPO and RTO for different data tiers, then design a multi-region DR strategy that leverages AWS services like Amazon RDS Multi-AZ and cross-region read replicas, prioritizing critical data for faster recovery. Option B. Implement a strategy of replicating all database data to a single, geographically distant AWS region using asynchronous replication, assuming this provides sufficient protection against any disaster scenario. Option C. Prioritize the lowest cost AWS storage option for all database backups, ensuring that the backup data is retained for the maximum period allowed by compliance, without specific consideration for recovery speed. Option D. Rely on daily manual backups of the database stored on local network attached storage NAS within the same data center as the primary database. The correct answer is A. Conduct a thorough business impact analysis to define RPO and RTO for different data tiers. Then design a multi-region DR strategy that leverages AWS services like Amazon RDS Multi-AZ and cross-region read replicas, prioritizing critical data for faster recovery. Explanation. This scenario presents a common challenge in cloud database management, balancing robust disaster recovery, DR, with cost-effectiveness and operational efficiency. The professional challenge lies in accurately assessing the potential impact of various disruptive events on critical business functions, and then selecting the most appropriate DR strategy that aligns with regulatory compliance and business objectives, without overinvesting in unnecessary redundancy. Careful judgment is required to translate abstract risks into concrete technical solutions. The correct approach represents best professional practice because it directly addresses the core tenets of disaster recovery, planning as mandated by regulatory frameworks like those governing financial services or healthcare in the U.S. A comprehensive risk assessment, which includes identifying critical business processes, quantifying potential data loss (RPO) and downtime (RTO), and evaluating the likelihood and impact of various threats, forms the foundation for an effective DR strategy. This aligns with the principle of due diligence, ensuring that an organization's data and operations are protected to a degree commensurate with their criticality and regulatory requirements. By prioritizing based on business impact and regulatory mandates, resources are allocated efficiently to mitigate the most significant risks. An incorrect approach that focuses solely on replicating all data to a distant region, without a clear understanding of RPO/RTO requirements for different data tiers, is professionally unacceptable. This fails to meet the regulatory requirement for proportionality and cost-effectiveness. It can lead to unnecessary expenditure and increased complexity without a corresponding increase in resilience for critical systems, potentially violating principles of prudent financial management and efficient resource utilization. Another incorrect approach that relies on manual backup stored locally is also professionally unacceptable. This method is highly susceptible to localized disasters, e.g., fire, flood, cyber attack, that could destroy both the primary data and the backup simultaneously. It fails to meet the regulatory expectation for independent off-site data protection and significantly increases the risk of prolonged downtime and irretrievable data loss, violating the duty of care to protect sensitive information and maintain business continuity. A third incorrect approach that prioritizes the cheapest available storage for all backups without considering access speed or recovery capabilities is professionally unsound. While cost is a factor, it cannot supersede the ability to meet defined RTOs. If critical data cannot be recovered within the acceptable downtime window due to slow retrieval from low-cost storage, the organization faces significant regulatory penalties and business disruption, demonstrating a failure to adequately plan for recovery. The professional decision-making process for similar situations should involve a structured risk assessment framework. This begins with identifying critical business processes and their associated data. Next, define the recovery point objective (RPO) and recovery time objective (RTO) for each process, informed by business impact analysis and regulatory requirements. Then, evaluate potential threats and their likelihood. Finally, design and implement DR solutions that meet these defined RPO/RTO targets in a cost-effective and compliant manner, with regular testing and review. Question 10. Process analysis reveals that the existing customer database schema, designed with a single customers table, is becoming insufficient to support new business initiatives, requiring granular customer segmentation based on purchase history, demographics, and engagement levels. The marketing department needs to target specific customer groups with tailored campaigns, and the current structure makes it difficult to assign multiple, distinct segments to a single customer without data duplication or complex workarounds. The development team is tasked with redesigning the data model to accommodate this evolving requirement while ensuring data integrity and future scalability. Which of the following database design approaches best addresses this implementation challenge? Option A. Add multiple Boolean flag columns to the customer's table, one for each potential segment, e.g., is high value as new customer is loyal. Option B. Modify the customer's table by adding a new text column to store a comma-separated list of segment names for each customer. Option C. Create a separate customer segments table that directly mirrors the customer's table, duplicating customer information for each segment they belong to. Option D. Introduce a new segments entity to store segment definitions and a customer segments junction table to establish a many-to-many relationship between customers and segments. The correct answer is D. Introduce a new segments entity to store segment definitions, and a customer segments junction table to establish a many-to-many relationship between customers and segments. Explanation. Scenario analysis. This scenario presents a common challenge in database design where evolving business requirements necessitate changes to an existing entity relationship, or model. The challenge lies in balancing the need for data integrity and consistency with the flexibility required to adapt to new business rules, specifically around customer segmentation. A poorly executed design change can lead to data anomalies, performance degradation, and difficulties in future development. The professional must consider the long-term implications of their design choices on data quality and system maintainability. Correct approach analysis. The correct approach involves a careful analysis of the new segmentation requirement and its impact on the existing customer data model. Introducing a new, separate entity for customer segments, linked to the customer entity via a many-to-many relationship, using a junction table, is the most robust and scalable solution. This adheres to normalization principles, specifically third normal form 3NF, by avoiding redundancy and ensuring that non-key attributes are dependent on the primary key. This design allows for multiple segments per customer and multiple customers per segment without data duplication. It also provides flexibility to add new segmentation criteria or modify existing ones without altering the core customer table, thus maintaining data integrity and simplifying future queries and application logic. This aligns with best practices for database design, emphasizing modularity and maintainability, which are crucial for long-term system health and compliance with data governance principles that mandate accurate and consistent data representation. Incorrect approaches analysis. One incorrect approach would be to add a new column to the existing customer table to store segment information. This violates normalization principles by potentially leading to data redundancy if a customer belongs to multiple segments, requiring multiple rows for the same customer or a delimited list in a single column, both problematic. It also creates update anomalies, where changing a segment's description might require updating multiple rows, increasing the risk of inconsistencies. This approach hinders scalability and makes querying for customers within specific segments inefficient and error-prone, failing to uphold data integrity standards. Another incorrect approach would be to directly embed segment details within the customer table without a proper relational structure, perhaps by creating numerous Boolean flags for each possible segment. This is highly inflexible, as adding a new segment would require altering the table schema, a costly and risky operation. It also leads to sparse tables with many null values, impacting storage efficiency and query performance. This design lacks the adaptability required for evolving business needs and compromises data quality by making it difficult to manage and query segment assignments accurately, thus failing to meet professional standards for maintainable and scalable database solutions. Professional reasoning. Professionals should approach such design challenges by first thoroughly understanding the business requirement and its implications. They should then evaluate potential design solutions against established database design principles, such as normalization, scalability, and maintainability. A critical step is to consider the impact on data integrity, query performance, and future extensibility. When faced with changes, the default should be to favor designs that minimize redundancy and maximize flexibility, even if they involve slightly more complexity initially. This proactive approach prevents technical debt and ensures the database remains a reliable foundation for business operations. Question 11. Stakeholder feedback indicates that certain user groups are experiencing significantly slower response times when querying specific datasets within our document database, while other user groups appear to have consistently faster access. This disparity is attributed to the current indexing strategy, which seems to be heavily optimized for the queries of the faster access groups. As a database specialist, what is the most appropriate course of action to address this situation? Option A. Dismiss the stakeholder feedback as a minor inconvenience, assuming that the current indexing strategy is sufficient for the majority of users and that the affected groups are experiencing isolated issues. Option B. Focus solely on altering the document database's schema to accommodate the specific query needs of the slower user groups, without considering the broader implications for existing data structures or the performance of other query types. Option C. Immediately implement the suggested performance optimizations for the slower user groups by creating new, highly specific indexes, without further analysis of the existing indexing strategy or its impact on other users. Option D. Conduct a comprehensive review of the document database's indexing strategy, query patterns, and schema design to identify the root cause of the performance disparity, and develop a balanced solution that optimizes performance for all user groups while maintaining data integrity. The correct answer is D. Conduct a comprehensive review of the document database's indexing strategy, query patterns, and schema design to identify the root cause of the performance disparity, and develop a balanced solution that optimizes performance for all user groups while maintaining data integrity. Explanation. Scenario analysis. This scenario presents a professional challenge due to the inherent tension between optimizing performance for a specific user group and ensuring equitable access and data integrity for all stakeholders. The feedback highlights a potential for bias in data retrieval and processing, which can have significant implications for fairness, compliance, and the overall trustworthiness of the system. The AWS Certified Database Specialty Exam focuses on practical application of AWS database services, including understanding their limitations and best practices for their use. In this context, the challenge lies in applying knowledge of document database characteristics, like flexible schemas and indexing, to address a real-world ethical and performance concern within the AWS ecosystem. Correct approach analysis. The correct approach involves a comprehensive review of the document database's indexing strategy and query patterns. Document databases like Amazon DocumentDB, with MongoDB compatibility, or Amazon DynamoDB, when used in a document-like fashion, rely heavily on efficient indexing to retrieve data quickly. If specific query patterns are consistently optimized for a subset of users, it can lead to suboptimal performance for others, or worse, inadvertently exclude them from timely data access. A thorough analysis of query logs, indexing strategies, and schema design is crucial. This aligns with best practices for database management, emphasizing performance tuning, data accessibility, and avoiding unintended consequences of optimization from a regulatory and ethical standpoint within the U.S. framework, as implied by AWS context. This approach promotes fairness and non-discrimination by ensuring that system performance does not disadvantage specific user groups without a justifiable technical or business reason, and that data is accessible to all authorized users. It also supports data integrity by ensuring that all data is retrievable and processable. Incorrect approach is analysis. One incorrect approach is to immediately implement the suggested performance optimizations without further investigation. This fails to consider the broader impact on other users and could exacerbate existing inequities or introduce new ones. Ethically, this demonstrates a lack of due diligence and a disregard for the principle of fairness. From a regulatory perspective, it could lead to violations if the optimized performance disproportionately benefits certain groups while hindering others, potentially impacting compliance with accessibility or non-discrimination laws. Another incorrect approach is to dismiss the stakeholder feedback outright, assuming it is a minor issue or a misunderstanding of the system. This is professionally irresponsible and ethically unsound, as it ignores legitimate concerns raised by users. It also represents a failure to adhere to best practices in system monitoring and user support. Regulatory implications could arise if the ignored feedback pertains to issues that, if addressed, would ensure compliance with data access or privacy regulations. A third incorrect approach is to focus solely on the technical aspects of the document database, such as schema changes, without considering the underlying business logic or user requirements that led to the feedback. This can result in a technically sound but functionally inadequate solution. Ethically, it shows a lack of empathy and user centricity. Regulatory concerns might emerge if the proposed technical solution inadvertently creates new compliance gaps or fails to address existing ones related to data usage and access. Professional reasoning. Professionals should adopt a structured approach to address stakeholder feedback. This involves active listening, thorough investigation, impact assessment, and collaborative solution development. The process should prioritize understanding the root cause of the issue, evaluating potential solutions against technical feasibility, performance implications, cost effectiveness, and importantly, Ethical and regulatory compliance. When dealing with database performance and access, it is crucial to consider the principle of equitable treatment and ensure that optimizations do not create unintended barriers or disadvantages for any user group. This systematic approach, grounded in a commitment to fairness and compliance, is essential for maintaining trust and operational integrity. Question 12. The efficiency study reveals that a critical customer-facing database is experiencing intermittent performance degradation, leading to increased latency and occasional timeouts. The database team suspects recent application code deployments and configuration changes as potential culprits. What is the most prudent approach to diagnose and resolve this issue while minimizing risk to data integrity and system availability? Option A. Continue normal operations and monitor the database, assuming the performance issues are temporary and will self-correct over time. Option B. Immediately revert all recent application code deployments and configuration changes to the last known stable state without extensive testing to restore performance quickly. Option C. Initiate a phased rollback of recent application code deployments and configuration changes, testing the database's performance and stability after each rollback step. Option D. Implement a hotfix directly into the production database to optimize query performance, assuming the changes will resolve the degradation. The correct answer is C. Initiate a phased rollback of recent application code deployments and configuration changes, testing the database's performance and stability after each rollback step. Explanation. Scenario analysis. The scenario presents a common challenge in database administration, where a critical system's performance degradation impacts business operations. The urgency to resolve the issue while ensuring data integrity and compliance with AWS best practices and potential regulatory requirements. Though not explicitly stated as US-specific, the context implies adherence to general cloud security and data governance principles, creates professional pressure. Balancing immediate fixes with long-term stability and security is paramount. Correct approach analysis. Implementing a phased rollback strategy, starting with the most recent, least impactful changes and thoroughly testing each step before proceeding, represents best professional practice. This approach minimizes the risk of further data corruption or system instability. It aligns with the principle of least privilege and controlled change management, which are fundamental to secure and reliable database operations. This methodical approach also facilitates easier identification of the root cause if the issue persists. Incorrect approaches analysis. A rapid, unverified rollback of all recent changes without proper testing or documentation is a significant regulatory and ethical failure. It risks introducing new, unforeseen issues, potentially violating data integrity principles and leading to data loss or corruption. This bypasses established change management protocols, which are often implicitly or explicitly required for auditability and compliance. Implementing a hotfix that directly modifies production data without a thorough understanding of its impact or a rollback plan is highly risky. This could lead to irreversible data corruption, violating data integrity, and potentially breaching compliance requirements related to data accuracy and availability. It demonstrates a lack of due diligence and adherence to secure coding and deployment practices. Ignoring the performance degradation and continuing with normal operations, hoping the issue resolves itself, is a failure of professional responsibility and potentially a breach of service-level agreements, SLAs. This inaction can lead to prolonged business disruption, data loss due to system instability, and reputational damage, all of which have ethical and potentially regulatory implications if data availability or integrity is compromised. Professional reasoning. Professionals should approach such incidents by first prioritizing data integrity and system stability. A structured incident response plan, including clear communication channels, root cause analysis, and a controlled remediation process, is essential. This involves documenting all actions, testing changes rigorously, and ensuring rollback capabilities are in place. Adherence to change management policies and security best practices, even under pressure, is critical for maintaining trust and compliance. Question 13. Implementation of a new e-commerce platform requires careful consideration of data consistency for various components, including product catalog, user profiles, and order processing. The development team is evaluating NoSQL database options to leverage scalability and performance. For the order processing module, which handles financial transactions, and requires the highest level of data accuracy to prevent discrepancies, which no SQL database characteristic should be prioritized. Option A. A built-in mechanism for automatic data reconciliation across all distributed nodes to simulate strong consistency. Option B. A default configuration that enforces eventual consistency across all data partitions for maximum availability. Option C. The ability to configure tunable consistency levels, allowing for strongly consistent reads for critical transactions. Option D. A schemaless design that allows for flexible data ingestion without regard for data integrity during read operations. The correct answer is C. The ability to configure tunable consistency levels, allowing for strongly consistent reads for critical transactions. Explanation. Scenario analysis. This scenario presents a common challenge in modern application development where data consistency requirements clash with the inherent scalability and performance benefits of NoSQL databases. Developers must balance the need for strong consistency, often critical for financial transactions or user authentication, with the distributed nature of many NoSQL solutions that prioritize availability and partition tolerance. The challenge lies in selecting the appropriate NoSQL database and configuring it to meet specific application needs without compromising data integrity or introducing unacceptable latency. Correct approach analysis. Choosing a NoSQL database that offers tunable consistency levels, such as Amazon DynamoDB with its strongly consistent read option, represents best professional practice. This approach allows developers to explicitly define the consistency model required for specific operations. For operations demanding absolute data accuracy, like financial transactions, selecting strongly consistent reads ensures that the most up-to-date data is retrieved, thereby preventing potential data discrepancies and adhering to the implicit regulatory expectation of accuracy in financial record keeping. This aligns with the principle of least privilege for consistency, applying stronger guarantees only where necessary. Incorrect approach is analysis. Opting for a NoSQL database that only offers eventual consistency for all operations, without considering the application's specific needs, is a significant regulatory and ethical failure. For sensitive data where accuracy is paramount, relying solely on eventual consistency can lead to outdated information being presented or processed, potentially violating data integrity requirements and leading to incorrect business decisions or compliance breaches. This demonstrates a lack of due diligence in understanding data sensitivity and its implications. Another incorrect approach is to over-engineer by selecting a distributed relational database or a complex multi-master relational setup, when a NoSQL solution with tunable consistency would suffice. This not only increases operational overhead and cost, but also misses the performance and scalability advantages of NoSQL for other parts of the application that do not require strong consistency. Ethically, this represents a waste of resources and a failure to apply the most efficient and appropriate technology. Furthermore, implementing a custom, complex synchronization mechanism on top of an eventually consistent NoSQL database to achieve strong consistency is also professionally unsound. This approach is prone to errors, difficult to maintain, and negates the simplicity and managed nature of cloud-native NoSQL services. It introduces significant technical debt and increases the risk of subtle data corruption, which can have severe regulatory implications if data accuracy is compromised. Professional reasoning. Professionals should approach this by first thoroughly understanding the data access patterns and consistency requirements for each component of the application. This involves categorizing data based on its criticality and the impact of stale reads. For critical data, prioritize databases or configurations that offer strong consistency options. For less critical data, leverage eventual consistency for performance and scalability benefits. Always consult relevant AWS documentation and best practices for the chosen database service to understand its consistency models and configuration options. This systematic evaluation ensures that the chosen solution is both technically sound and compliant with implicit data integrity expectations. Question 14. Process analysis reveals that a financial services firm is migrating its customer transaction history to a NoSQL database. The firm operates under strict U.S. regulatory requirements for data integrity, auditability, and non-repudiation of financial records. Which of the following NoSQL data modeling approaches best satisfies these regulatory mandates while leveraging the benefits of NoSQL? Option A. Model transaction data using a denormalized structure where sensitive details are omitted from historical records to simplify access control. Option B. Design the data model to store each transaction as an immutable document with a unique version identifier and a timestamp, ensuring that all historical states are preserved and auditable. Option C. Utilize a NoSQL database that primarily focuses on eventual consistency for all data, including transaction history, to maximize read availability. Option D. Implement a data model that allows for in-place updates of transaction records to optimize query performance and reduce storage footprint. The correct answer is B. Design the data model to store each transaction as an immutable document with a unique version identifier and a timestamp, ensuring that all historical states are preserved and auditable. Explanation. Scenario analysis. This scenario presents a professional challenge in designing a NoSQL data model for a financial services application that handles sensitive customer data. Core difficulty lies in balancing the flexibility and scalability benefits of NoSQL with the stringent regulatory requirements for data integrity, auditability, and access control inherent in financial services. The need to comply with specific U.S. regulations, such as those governing financial data handling and privacy, adds a layer of complexity. Incorrect data modeling choices can lead to significant compliance failures, data breaches, and reputational damage. Correct approach analysis. The correct approach involves selecting a NoSQL database and data modeling strategy that inherently supports the required audit trails and immutability for financial transactions. For instance, using a document database like Amazon DocumentDB with MongoDB compatibility, or a key value store like Amazon DynamoDB, and designing the data model to include versioning, timestamps, and immutable records for each transaction. This ensures that every change is logged, traceable, and cannot be altered without leaving a clear audit trail, directly addressing regulatory mandates for data integrity and auditability in financial systems. This aligns with best practices for secure and compliant data management in regulated industries. Incorrect approach is analysis. An approach that prioritizes only performance and ease of querying without explicit consideration for auditability and immutability would be a significant regulatory failure. For example, using a NoSQL database that allows in-place updates of historical transaction records without maintaining a version history or audit log would violate the principle of data integrity and make it impossible to reconstruct past states of data, which is critical for regulatory compliance and dispute resolution. Another failure would be to implement access control solely at the application layer, without leveraging the database's native security features for fine-grained access to sensitive financial data, increasing the risk of unauthorized access and data breaches, which is a direct violation of data protection regulations. Lastly, choosing a NoSQL database that does not offer robust mechanisms for data durability and backup, or one where data partitioning strategies compromise data consistency for transactional data, would also be a failure, as it jeopardizes the availability and integrity of critical financial records. Professional reasoning. Professionals must adopt a risk-based approach, starting with a thorough understanding of the applicable U.S. regulatory framework, e.g., SEC rules, FINRA regulations, and relevant data privacy laws like CCPA, if applicable to the customer base. This understanding should then inform the selection of the NoSQL database technology and the design of the data model. The decision-making process should prioritize solutions that inherently support compliance requirements like immutability, auditability, and robust security. Regular consultation with legal and compliance teams is essential throughout the design and implementation phases to ensure ongoing adherence to regulatory mandates. Question 15. Assessment of the most effective and professional approach for a database specialist to address a stakeholder's urgent request for significant database performance improvements on AWS, given limited initial information about the root cause. Option A. Immediately scale up the Amazon RDS instance type to a larger, more powerful option to provide immediate relief, and then investigate the performance issues later. Option B. Focus exclusively on rewriting the most frequently executed queries to improve their efficiency, assuming that query execution is the sole cause of performance degradation. Option C. Initiate a comprehensive profiling and monitoring exercise using AWS tools like CloudWatch and Performance Insights, followed by a systematic analysis of query performance, schema, indexing, and configuration parameters to identify specific bottlenecks before proposing targeted solutions. Option D. Apply a set of commonly recommended database tuning parameters and query optimization techniques found in general online resources, without specific analysis of the current workload. The correct answer is C. Initiate a comprehensive profiling and monitoring exercise using AWS tools like CloudWatch and Performance Insights, followed by a systematic analysis of query performance, schema, indexing, and configuration parameters to identify specific bottlenecks before proposing targeted solutions. Explanation: scenario analysis. This scenario presents a common challenge in database management, balancing performance improvements with the potential for disruption and cost implications. The stakeholders' request for immediate, significant performance gains without a clear understanding of the underlying issues or the associated risks creates a professionally challenging situation. It requires a database specialist to not only possess deep technical knowledge, but also strong communication and stakeholder management skills. The pressure to deliver quickly, coupled with the inherent complexity of database systems, necessitates a methodical and risk-aware approach. Correct approach analysis. The correct approach involves a systematic, data-driven methodology that prioritizes understanding the root cause of performance degradation before implementing solutions. This aligns with best professional practices by ensuring that interventions are targeted, effective, and minimize unintended consequences. Specifically, it involves 1. Profiling and monitoring, utilizing AWS CloudWatch metrics, performance insights, and database-native tools to gather detailed information on query execution, resource utilization, CPU, memory, I/O, and wait events. This provides an objective baseline and identifies specific bottlenecks. 2. Query optimization. Analyzing slow-running queries identified during profiling to determine if they can be rewritten, if indexes are missing or inefficient, or if execution plans can be improved. 3. Schema and index review. Evaluating the database schema and existing indexes for suitability and potential improvements, such as adding composite indexes or reorganizing existing ones. 4. Parameter tuning. Adjusting database configuration parameters, e.g., buffer pool sizes, connection limits, based on observed workload patterns and resource availability, ensuring changes are incremental and tested. 5. Cost-benefit analysis. Presenting findings and proposed solutions to stakeholders, including the expected performance improvement, the effort required, potential risks, and associated costs, e.g., instance type changes, additional storage. This fosters transparency and informed decision-making. This approach represents best professional practice because it is grounded in evidence, minimizes risk, and ensures that solutions are tailored to the specific problem. It avoids speculative changes that could worsen performance or incur unnecessary costs. Incorrect approaches analysis. Implementing broad, unverified changes without proper diagnosis is professionally unacceptable and carries significant regulatory and ethical implications. One incorrect approach involves immediately scaling up the database instance type without understanding the performance bottleneck. This is a costly and potentially ineffective solution. Ethically, it represents a failure to act as a responsible steward of company resources. It could also lead to regulatory scrutiny if it results in significant, unjustified expenditure, especially in regulated industries where cost control and efficiency are paramount. Another incorrect approach is to blindly apply generic best practice tuning parameters found online without correlating them to the specific workload and environment. This demonstrates a lack of due diligence and technical rigor. It can lead to suboptimal performance, instability, and potential data corruption, violating the professional duty to provide competent service. A third incorrect approach is to focus solely on query rewriting without considering underlying infrastructure or schema issues. While query optimization is important, it is only one piece of the puzzle. Neglecting other potential causes of poor performance can lead to wasted effort and continued performance problems, failing to meet the professional obligation to deliver comprehensive solutions. Professional reasoning. When faced with a stakeholder request for rapid performance improvements, a professional database specialist should follow a structured decision-making process. 1. Understand the business context. Clarify the business impact of the performance issue and the urgency. 2. Gather information. Collect all available metrics and logs to form a comprehensive picture of the database's behavior. 3. Diagnose the root cause. Systematically identify the primary bottlenecks through analysis of collected data. 4. Propose solutions. Develop a set of targeted evidence-based solutions, prioritizing those with the highest impact and lowest risk. 5. Communicate and collaborate. Present findings, proposed solutions and their implications, performance, cost, risk, to stakeholders for informed decision-making. 6. Implement and monitor. Execute approved changes methodically, with robust monitoring to validate effectiveness and detect regressions. 7. Iterate. Continuously refine the approach based on ongoing monitoring and feedback. This process ensures that technical decisions are aligned with business objectives, are technically sound, and are executed responsibly. Question 16. Comparative studies suggest that in financial database systems operating under U.S. regulatory frameworks, ensuring the integrity of transaction data is paramount to prevent fraudulent activities and maintain accurate financial reporting. A critical business rule dictates that all recorded financial transactions must have a positive monetary value, which database constraint, when applied to a transaction amount column, would best enforce this rule and align with regulatory expectations for data accuracy. Option A. A check constraint ensuring the transaction amount is greater than 0. Option B. A primary KEY constraint on the transaction amount column. Option C. A foreign KEY constraint referencing a table of valid transaction amounts. Option D. A unique constraint on the transaction amount column. Correct answer is A. A check constraint ensuring the transaction amount is greater than 0. Explanation. Scenario analysis. This scenario presents a common challenge in database design within regulated industries, ensuring data integrity and compliance with financial reporting standards. The professional challenge lies in selecting the most appropriate constraint to enforce business rules that prevent erroneous financial transactions, thereby safeguarding against regulatory penalties and maintaining auditability. The need for absolute accuracy and immutability of financial data necessitates careful consideration of how database constraints can proactively prevent data anomalies. Correct approach analysis. Implementing a check constraint on the transaction amount column to ensure it is always greater than 0 directly aligns with financial regulatory principles that prohibit 0 or negative transaction amounts for valid financial entries. This approach provides a granular, data-level enforcement mechanism that prevents invalid data from ever being inserted or updated, which is crucial for maintaining the integrity of financial records required by regulatory bodies. This proactive prevention is a cornerstone of robust data governance and compliance. Incorrect approaches analysis. Using a primary KEY constraint on transaction amount is fundamentally incorrect because transaction amounts are not unique identifiers for individual transactions. Multiple transactions can have the same amount, and a primary key must uniquely identify each row. This would violate the core purpose of a primary key and lead to data integrity issues, potentially masking or preventing the recording of legitimate transactions, which is a regulatory failure. Employing a foreign KEY constraint on transaction amount is also inappropriate. A foreign key establishes a relationship between tables by referencing a primary key in another table. The transaction amount itself does not inherently represent a relationship to another entity's primary key in a way that would be enforced by a foreign key. Attempting to use it this way would misapply the constraint's purpose and fail to enforce the business rule, leading to potential data inconsistencies that could violate financial reporting standards. Applying a unique constraint to transaction amount would prevent duplicate transaction amounts. While this might seem beneficial in some contexts, it is not suitable for financial transactions where multiple entries can legitimately share the same monetary value. This would incorrectly restrict the recording of valid financial activities, leading to data loss and an incomplete financial picture, which is a direct contravention of regulatory requirements for accurate financial reporting. Professional reasoning. When faced with enforcing business rules that have direct regulatory implications, professionals must prioritize constraints that offer the most precise and proactive data validation. The decision-making process should involve 1. Understanding the specific business rule and its regulatory context. 2. evaluating how each available database constraint, primary key, foreign key, unique check, can enforce that rule. 3. Selecting the constraint that most accurately and effectively prevents invalid data at the point of entry or modification, thereby ensuring data integrity and compliance. In financial contexts, check constraints are often the most appropriate for enforcing value-based business rules. Question 17. System analysis indicates a healthcare organization is migrating its patient database to AWS and must ensure strict adherence to HIPAA regulations. The organization needs a managed database service that supports encryption at rest and in transit, granular access control, and comprehensive audit logging. Which of the following approaches best aligns with HIPAA compliance requirements for this scenario? Option A. Choosing Amazon Aurora Serverless, ensuring data is encrypted at rest by default, and relying on application-level logic for access control and auditing. Option B. Migrating the database to an EC2 instance and managing all encryption, access control, and auditing manually using open-source tools. Option C. Utilizing Amazon DynamoDB with server-side encryption enabled, relying on DynamoDB's built-in access control mechanisms, and enabling DynamoDB streams for change logging. Option D. Deploying Amazon RDS with multi-AZ deployment, enabling encryption at rest using AWS KMS, configuring SSL/TLS for in-transit encryption, and implementing fine-grained IAM policies for access control, supplemented by AWS CloudTrail for auditing database events. The correct answer is D. Deploying Amazon RDS with multi-AZ deployment, enabling encryption at rest using AWS KMS, configuring SSL/TLS for in-transit encryption, and implementing fine-grained IAM policies for access control, supplemented by AWS CloudTrail for auditing database events. Explanation. Scenario analysis. This scenario presents a common challenge in cloud database management, balancing the need for robust data protection with operational efficiency and cost-effectiveness, particularly when dealing with sensitive data subject to stringent regulations like HIPAA. The challenge lies in selecting the most appropriate AWS services and configurations that meet both compliance requirements and business objectives without introducing unnecessary complexity or security risks. A misstep can lead to significant regulatory penalties, reputational damage, and loss of customer trust. Correct approach analysis. The correct approach involves leveraging AWS services that are specifically designed and certified for HIPAA compliance, such as Amazon RDS with encryption at rest and in transit, and implementing appropriate access controls and auditing mechanisms. AWS provides a shared responsibility model where AWS is responsible for the security of the cloud, and the customer is responsible for security in the cloud. For HIPAA, this means utilizing AWS services that are covered under the AWS Business Associate Addendum, BA, and configuring them to meet the specific requirements of the HIPAA security rule. Encryption of data at rest and in transit is a fundamental requirement. Implementing granular access controls using IAM policies and enabling detailed logging and monitoring with services like CloudTrail and CloudWatch are crucial for demonstrating compliance and detecting potential breaches. Regularly reviewing and updating these configurations based on evolving threats and regulatory guidance is also a best practice. Incorrect approaches analysis. Implementing a solution without explicitly verifying HIPAA compliance of the chosen AWS services is a significant regulatory failure. Relying solely on general security best practices without understanding the specific mandates of HIPAA can leave sensitive patient data vulnerable and non-compliant. For instance, using a database service that is not covered under a BAA or failing to enable encryption for data at rest would directly violate HIPAA requirements. Another failure would be neglecting to implement robust access controls, allowing unauthorized personnel to access protected health information. 5. This lack of granular control and auditing is a direct contravention of the HIPAA security rules requirements for access management and audit trails. Furthermore, choosing a solution that does not offer comprehensive logging and monitoring capabilities hinders the ability to detect security incidents and investigate them, which is a critical component of HIPAA compliance. Professional reasoning. Professionals must adopt a risk-based approach, prioritizing compliance with relevant regulations. This involves a thorough understanding of the regulatory landscape, e.g., HIPAA in the US for healthcare data, and mapping those requirements to the capabilities of cloud services. The decision-making process should involve 1. Identifying all applicable compliance standards. 2. Researching AWS services that are certified or designed to meet those standards and are covered under relevant agreements, like a BAA for HIPAA. 3. Designing a solution that incorporates specific compliance features such as encryption, access control, and auditing. 4. Implementing and continuously monitoring the solution to ensure ongoing adherence to regulations and security best practices. 5. Regularly reviewing and updating the architecture and configurations in response to changes in regulations or the threat landscape. Question 18. To address the challenge of ensuring continuous data availability and meeting stringent regulatory data retention requirements for a critical financial services database hosted on AWS RDS, which backup and recovery strategy best aligns with industry best practices and compliance mandates? Option A. Implement automated daily snapshots of the database, coupled with frequent transaction log backups e.g. every 15 minutes, and configure automated retention policies for both snapshots and logs to align with regulatory data archival periods. Option B. Schedule automated full database backups once a week and store them in a separate AWS region, without implementing transaction log backups. Option C. Rely on manual, weekly full database backups performed by the operations team and stored on local network-attached storage. Option D. Configure automated daily snapshots only, with no transaction log backups, and set a very long retention period for all backups to ensure data is always available. The correct answer is A. Implement automated daily snapshots of the database, coupled with frequent transaction log backups, e.g., every 15 minutes, and configure automated retention policies for both snapshots and logs to align with regulatory data archival periods. Explanation. Scenario analysis. This scenario presents a common yet critical challenge in database management, ensuring data integrity and availability in the face of potential disruptions, while adhering to stringent regulatory requirements for data retention and recovery. The professional challenge lies in balancing operational efficiency, cost-effectiveness, and robust disaster recovery capabilities with the absolute necessity of meeting compliance mandates. The complexity arises from the need to select a backup and recovery strategy that not only protects against data loss, but also satisfies specific audit and regulatory demands, which often dictate RPO recovery point objective and RTO recovery time objective parameters. Correct approach analysis. The correct approach involves implementing a multi-layered backup strategy that leverages AWS services to meet defined RPO and RTO targets, while also ensuring compliance with data retention policies. This typically includes automated daily snapshots of the database, which are stored in a durable, geographically redundant location. Furthermore, transaction log backups should be configured to run at a higher frequency, e.g., every 15 minutes, to minimize data loss in the event of a failure. These transaction logs are crucial for point-in-time recovery, allowing restoration to a specific moment before an incident. The retention policy for both snapshots and logs must be clearly defined and automated to ensure compliance with regulatory requirements for data archival and auditability. This approach directly addresses the need for minimal data loss, low RPO, and rapid recovery, low RTO, by combining full backups with granular transaction log backups, all managed within a compliant framework. Incorrect approach is analysis. One incorrect approach is relying solely on manual, infrequent full backups stored locally. This fails to meet the RPO and RTO requirements for most critical applications and regulatory frameworks. Manual backups are prone to human error, inconsistency, and delays, making them unreliable for timely recovery. Furthermore, local storage offers no protection against site-wide disasters, violating the principle of data redundancy. Another incorrect approach is to only back up the database once a week without considering transaction logs. This would result in a significant potential data loss, up to a week's worth of transactions, if a failure occurs between backups, failing to meet typical RPO requirements for most regulated industries. The inability to perform point-in-time recovery also severely limits the ability to restore to a precise state before an incident, which is often a regulatory mandate. A third incorrect approach is to implement automated backups but configure them with excessively long retention periods that exceed regulatory requirements, leading to unnecessary storage costs and potential compliance issues related to data sprawl and management. A long retention might seem like a safeguard. It can complicate audits and increase the risk of storing data that is no longer legally required, potentially creating liabilities. Professional reasoning. Professionals must adopt a risk-based approach to database backup and recovery. This involves understanding the criticality of the data, the potential impact of data loss or downtime, and the specific regulatory and compliance obligations. Decision-making process should start with defining clear RPO and RTO objectives in consultation with stakeholders and legal/compliance teams. Subsequently, evaluate available technologies and services, like AWS RDS automated backups, snapshots, and transaction log backups, to determine the most cost-effective and reliable solution that meets these objectives. Automation is key to ensuring consistency and reducing human error. Regular testing of backup and recovery procedures is paramount to validate their effectiveness and ensure that recovery can be performed within the defined RTO. Finally, maintaining comprehensive documentation of the backup strategy, retention policies, and recovery procedures is essential for audits and knowledge transfer. Question 19. Quality control measures reveal that a critical financial transaction processing system on AWS RDS is experiencing intermittent data inconsistencies due to concurrent updates on shared account balance records. The system is subject to stringent financial regulations requiring absolute data integrity and auditability, which concurrency control strategy, when implemented on RDS, best addresses these requirements while maintaining reasonable system performance. Option A. Utilize pessimistic locking with row-level locks held for the entire duration of each transaction. Option B. Rely solely on the application's sequential processing logic without explicit database-level concurrency control. Option C. Develop a custom application-level locking mechanism to manage access to account balances. Option D. Implement optimistic locking, using version numbers stored with each account balance record. The correct answer is D. Implement optimistic locking using version numbers stored with each account balance record. Explanation. Scenario analysis. This scenario presents a common challenge in database management, where ensuring data integrity during concurrent transactions is paramount. The professional challenge lies in selecting a concurrency control mechanism that balances performance with the strict requirements of financial data accuracy, as mandated by regulatory frameworks governing financial institutions. Mismanagement of concurrent access can lead to data corruption, financial discrepancies, and ultimately, severe regulatory penalties and loss of customer trust. The need for robust transaction management is amplified in systems handling sensitive financial information. Correct approach analysis. Implementing optimistic locking is the best professional practice in this scenario. This approach assumes that conflicts are rare and allows transactions to proceed without acquiring locks upfront. Instead, it checks for conflicts only at the commit stage. If a conflict is detected, i.e., the data has been modified by another transaction since it was read, the transaction is rolled back and retried. This aligns with regulatory expectations for data integrity in financial systems by ensuring that committed data is always consistent. The AWS Certified Database Specialty Exam emphasizes understanding how to leverage database features for compliance. Optimistic locking, when properly implemented with versioning or timestamps, provides a mechanism to detect and resolve concurrent modification issues, thereby upholding the principle of transactional atomicity and consistency, which are foundational to financial regulations. It minimizes blocking, improving throughput, which is also a desirable characteristic in high-volume financial transaction systems, without compromising accuracy. Incorrect approaches analysis. Using pessimistic locking without careful consideration is professionally unacceptable. While pessimistic locking prevents conflicts by acquiring locks before data modification, it can lead to significant performance degradation and deadlocks, especially in high-concurrency environments. In financial systems, prolonged lock contention can delay critical transactions, potentially violating service-level agreements and regulatory requirements for timely processing of financial operations. Furthermore, improper lock management can lead to starvation of transactions. Implementing a custom, ad hoc locking mechanism that bypasses standard database transaction isolation levels is a severe regulatory and ethical failure. Such an approach introduces significant risks of race conditions, data corruption, and inconsistent states that are difficult to audit and debug. It directly contravenes the principles of atomicity, consistency, isolation, durability, that are implicitly or explicitly required by financial regulations to ensure the reliability and integrity of financial records. This lack of adherence to established, well-tested database transaction management principles makes the system inherently unreliable and non-compliant. Failing to implement any form of concurrency control and relying solely on the application layer to manage concurrent access is also a critical failure. This approach is highly prone to errors, as it is extremely difficult to correctly manage complex concurrent access scenarios at the application level without introducing subtle bugs that can lead to data inconsistencies. This directly violates the regulatory expectation of maintaining accurate and auditable financial records, as it creates a high probability of data integrity breaches that would be difficult to trace and rectify, leading to potential regulatory sanctions. Professional reasoning. Professionals must first understand the specific regulatory landscape governing the data being managed, particularly for financial applications. This involves identifying requirements for data integrity, auditability, and transactional consistency. Next, they should evaluate the characteristics of the workload, including transaction volume, read/write patterns, and the acceptable level of latency. Based on these factors, they can then select the most appropriate concurrency control mechanism. For financial data, where integrity is paramount, a mechanism that guarantees consistency, even at the cost of occasional retries, is preferred. This involves a deep understanding of database transaction isolation levels and locking strategies, and how they map to compliance requirements. The decision-making process should prioritize robustness and auditability over raw performance if there is any risk to data integrity. Question 20. The control framework reveals that financial services organization operating within the United States requires a highly available and durable Amazon RDS database to store critical transaction data. The primary concern is to minimize data loss and ensure rapid recovery in the event of an availability zone failure or an instance outage. The solution must comply with U.S. financial regulations mandating continuous access to financial records and preventing any loss of transactional integrity. Which of the following configurations best addresses these requirements? Option A. A single AZ Amazon RDS instance without any high availability or disaster recovery configurations. Option B. A single AZ Amazon RDS instance with read replicas in different AWS regions using asynchronous replication. Option C. A multi-AZ Amazon RDS deployment with synchronous replication to a standby instance in a different availability zone. Option D. A single AZ Amazon RDS instance with asynchronous cross-region read replicas and a manual failover procedure. The correct answer is D. A single AZ Amazon RDS instance with asynchronous cross-region read replicas and a manual failover procedure. Explanation. Scenario analysis. This scenario presents a common challenge in cloud database management, ensuring continuous availability of critical financial data while adhering to stringent regulatory requirements for data integrity and disaster recovery. The challenge lies in balancing the need for rapid failover and data consistency with the cost implications of implementing robust high-availability solutions. The AWS Certified Database Specialty exam expects candidates to understand how to design and implement database solutions that meet these demanding operational and compliance needs within the AWS ecosystem, specifically considering U.S. regulatory frameworks relevant to financial services. Correct approach analysis. Implementing a multi-AZ deployment for Amazon RDS with synchronous replication is the best professional practice in this context. This approach directly addresses the core HA requirement by providing automatic failover to a standby replica in a different availability zone in the event of an instance failure or AZ disruption. Synchronous replication ensures that data is written to both the primary and standby instances before a transaction is committed, guaranteeing zero data loss, RPO of 0, and near-instantaneous failover, low RTO. This aligns with U.S. financial regulations that mandate high data durability and availability to prevent service disruptions and data loss, which could have severe financial and reputational consequences. The AWS well-architected framework's reliability pillar also strongly advocates for multi-AZ deployments for critical workloads. Incorrect approaches analysis. Configuring a single AZ RDS instance with read replicas in different regions fails to meet the RPO requirement for zero data loss. Asynchronous replication used for cross-region read replicas means there's a potential for data loss during a failover event if the primary instance fails before changes are replicated to the standby. This is unacceptable for critical financial data, where even a single loss transaction can have significant implications and violate regulatory mandates for data integrity. Implementing a single AZ RDS instance without any HA configuration is fundamentally flawed for a critical financial database. It offers no protection against instance failures or AZ outages, leading to prolonged downtime and potential data loss, directly contravening regulatory expectations for business continuity and disaster recovery in the financial sector. Utilizing a single AZ RDS instance with a cross-region read replica and relying solely on manual failover procedures is also insufficient. While it offers some disaster recovery capability, the manual failover process introduces significant RTO delays and increases the risk of human error. Furthermore, the asynchronous nature of cross-region replication still poses a risk of data loss, making it unsuitable for the zero data loss requirement of critical financial data. Professional reasoning. Professionals must first identify the critical nature of the data and the associated regulatory compliance requirements. For financial data in the U.S., this typically means a zero RPO and a very low RTO. The next step is to evaluate AWS database services and their HA features against these requirements. Understanding the trade-offs between synchronous and asynchronous replication, single AZ versus multi-AZ deployments, and manual versus automatic failover is crucial. The decision-making process should prioritize solutions that demonstrably meet or exceed regulatory mandates for data durability, availability, and disaster recovery, while also considering operational efficiency and cost-effectiveness. The AWS well-architected framework serves as a guiding principle for designing robust and reliable cloud architectures.